Hello, in this video we will talk about t-distribution. So t-distribution is connected with normal and a chi-square distribution. So if we know psi and a chi-square n are two independent random variables with psi is following a standard normal distribution. So which means psi have zero mean and standard deviation 1 and is a normal random variable. And a chi-square n is a chi-squared distributed random variable with n degrees of freedom. Then we get a new random variable which is the division between psi and square root of chi-square n divided by n. So here division is a standard normal random variable divided by the square root of a chi-square distributed random variable with division of its degrees of freedom. So here t is called a t random variable with n degrees of freedom. So here n is the same as the degrees of freedom for the chi-square random variable. So if we look at this plot, including a standard normal random variables, probability density curve with dash curve, and this blue curve is for the t random variables, probability density curve, and with 5 degrees of freedom. So you can see there, these two curves will be quite close, but not the same, and the standard normal probability density curve has high peaked but lower tail, and t random variable has little lower for the peak value and a longer and a flat tail. But if the degrees of freedom for the t random variable is relatively large, for example over 30, then it's very close to the standard normal random variable. And the mean and the variance of t random variable we have seen from the previous figure that it is symmetrical, similar as normal distribution, and its mean is 0, and the variance for t random variable is degrees of freedom n divided by n minus 2. So you can see if n is very large, then the variance or standard deviation for t distribution is close to 1. And critical value is very important to be used in, for example, hypothesis testing and calculate the probability. So here we assume alpha is a value between 0 and 1. So here represents the probability. Then we can denote probability of t random variable larger than t alpha n. So here t alpha n is this value we call the critical value. So larger than this critical value, probability is alpha. So here alpha usually will be a relatively small value, for example 0.05. So in hypothesis testing, if we get t value, render the probability on the right side of its value is less than 0.05. or say less than alpha, then we can say the test is significant. And in a two-tailed test, if we get the t value less than the minus of t alpha n, we can also say it is significant. And because this is also symmetrical, so this area dash the blue area is same as this area. And we can also write probability of t random variable larger than minus t alpha n. So here is t minus t alpha n. So larger than this critical value is 1 minus alpha. So because this is also alpha, so this white area plus this blue area is 1 minus alpha. And similarly, because this is alpha, so this blue area plus this white area is also 1 minus alpha. So we will use this information in example. And you can also use R programming to calculate the probability or quantile value. So quantile value is the same meaning for the t critical value. So for example, we can use pt function in R to calculate the probability of random variable t less than x. So ptxn, which means we want to get the cumulative probability of all t values less than x, and this t distribution has n minus n degrees of freedom. So ptxn will get the probability of less than x. So this is a particular value or quantile value or the critical value. So ptxn will get this area from lowest to this value, this area. And if we use quantile or qt 1 minus alpha n means degrees of freedom, and 1 minus alpha, which means the cumulative probability, which will render the critical value t alpha n. So which means qt 1 minus alpha n will get this critical value given this cumulative probability for the blue area and the white area. So which means if we know their cumulative probability to the t alpha n, for example, is 0.95, then we can get this critical value using qt 1 minus alpha, because we know the alpha on the right side is alpha, so this is 1 minus alpha, and we input with 1 minus alpha and degrees of freedom for qt function. So next example, for example, we want to calculate the probability of t random variable with 12 degrees of freedom less than 1.4. So we can just use function pt 1.4 12 here. So 0.9. So which means in a t distribution with 12 degrees of freedom, this about 0. So this is 1.4 value, and this area, blue plus white, is about 0.9. And similarly, if we want to calculate t value for 0.25 and with 9 degrees of freedom, so we can use qt, because this is alpha 0.025, so 1 minus 0.025 as the input, because this is on the left side of this critical value we want to calculate. So input is 1 minus 0.025 and with 9 degrees of freedom. So qt of this is about 2.26. So which means we know alpha is 0.025. So this value is about 2.26. And this curve is a t distribution with 9 degrees of freedom. Thanks for watching.